Hello all, welcome to the another lecture with your C programming. So in this lecture, we are going to talk about the structures in C programming language. So what's a structure? Structure is basically nothing but it's a user-defined data type in C or C++, right? Structure is, it's a user-defined data type. Now you have three types of data types. You have basic type, you have the derived types, and then you have the user-defined. So structure comes under the user-defined type. Right? Okay. Now, what do you mean by user-defined data type? Now, all of you knows the meaning of what is a data type. Data type means the type of data. So you already have the built-in types. You have integer, you have float, you have double, or you have character. These are the basic types, right? Which are predefined. Now, let us say you want to create your own data type. Right? So to create your own data type, right? Not a built-in, but it's your user-defined data type. Just like you create a user-defined functions also, right? Similarly, you can create user-defined data type as well. So how you can create a user-defined data type? That is possible only by using the structures, right? So to create the user-defined data type using the structures, C and C++ language provides you a keyword, which is a struct keyword. Which keyword? It's a struct keyword. So using the struct keyword, you can create your own data type. For example, you can write struct, the name of your data type. Let's say I write my type. This is the name of my data type. Now, what will be the usage of my data type? The usage of a user-defined data type is basically you can create your own data type to store different types of elements, right? You can create your own data type to store different types of elements, or you can say different types of variables. Now, you already have one derived data type, which is the array, right? So when you use an array, under the array, you can store same type of elements. For example, you create an array of integers. So here you are storing only integer values, right? You want to create an array of characters. So you'll be creating an array of characters where there will be only characters. Example, A, B, C, and so on, followed by a null character, right? Now, let's say if you want to declare an array which stores multiple elements having different types. Let's say you write int array and then you mention the size, let's say 10, and you write 1, 2.3, character A, some string, let's say hello. Now, is it possible to do so using an array? No, obviously this is not possible. Why? Because over here, compiler will report an error. Compiler will say that here you are saying that array will consist of only integers, right? If it can consist of only integers, then how you are storing 2.3, a floating point number, a character, or a string? Obviously, it is not possible using an array. So we need some mechanism to store these kinds of elements. So this is done instead of using the array, we are going to make use of the structure. Just like over here, you are mentioning the elements in curly brackets. For the structure also, you are going to mention the different elements in the curly brackets. But it will not be the elements, it will be the variables, because you are going to define your data type first, right? So to create your user-defined data type, the first method is you're going to define template for the data type. The procedure will be you're going to define the template for the data type, that how your data type will look like. Now, after you have designed your data type, designing part is done. Now you can declare the variable of that type. Okay, now let's say you have the already built-in data type. You have integer. So integer data type is already designed. It's already there. It's built in. Now, since you already have this predefined data type, you easily declare the variable. You write int a. When the variable is declared, at this part, memory is allocated. Yes or no? Okay, so same portion, same concept will be applicable to the structures also. So when you are going to define a template for the data type, no memory will be allocated at this point, right? At this point, no memory will be allocated. Memory will be allocated only when you're going to declare a variable of your own type, which will be the structure type, right? So now let's first learn that how you're going to design your own data type, right? So for designing your own data type, you are going to use the syntax, and let me erase this one. So first you're going to write struct my type. Then after this, you will mention the curly bracket, just like you mentioned over here. Then you will close the curly bracket followed by a semicolon, right? Then inside this two curly brackets, you're going to mention the variables, the different variables. Let's say in my type, I want to have integer. I want to have a float value. I want to have a character value, right? But here mentioning only int, float and char, it will not be possible. You have to mention the name of the variable also. Int x, float y, char z. This is how you're going to design your data type, right? For example, let's say I want to create my own data type that can store date, so that I can access the month of the date, I can access year of the date, I can access day of the date separately. Let's say you want to print the information of students or employee who want to print the employee details on the basis of the year. Let's say when they joined the company, in which year did they join the company, right? So in that case, structures will be helpful. So how you're going to design the data type? For the date, you're going to write struct keyword. This is the keyword you need to write it to declare your own data type. If you don't write the struct keyword, you cannot declare the user defined data type. Struct, the name of the type, let's say date. Now you will create the curly bracket and you will mention the variable. What you need inside your data type? I need one month, int month. I need one day, let's say int day. And I need year, let's say int year. And then I will close by the terminating with the curly bracket and then putting a semicolon. So this is, I have designed my template for the data type. Now, as I told you, when you design a data type, no memory will be allocated. When the memory will be allocated? Memory will be allocated only when you are going to declare the variable of the type. Only then memory is going to be allocated, right? Now, next, how you are going to declare variable of the type date? Now let's, after designing the data type, so here we have designed, this is the designing part, design your type. Now your type is ready. After the type is ready, now you can declare the variable, right? So now let's declare variables. So the way to declare variable of your own type will be, you're going to write the type name, the data type, right? Followed by the variable name. This is how you write normally. This is how you declare the variable. You write data type name, int, then you write int. So what's the name of the data type over here? It is date. So you will write date. And let's say the name of the variable is date of birth. With, let's say, DOB. This is how we declare the structure variable. But we can do this one only in C++. In C, it is mandatory to write the struct keyword in front of the variable declaration. When your variable is of type user defined data type. So struct keyword writing in C, it is mandatory. Okay. In C, it is mandatory, but in C++, this keyword is optional. This is how we declare the variable. So when you declare a variable of a user defined type, only then memory will be allocated. Right? Okay. So now let's see how this memory allocation, it will actually look like, or how it is going to be represented. So let me erase this part over here. Okay, so here you have declared the variable DOB, right? And you can see that this DOB is having how many portions? It's having 3 portions and all are integers, right? So in using structure, you can have a structure type where you are having similar type of elements or you're having different types of elements. Both are required. It's not like that if you're going to declare the members or these variables inside the type as similar types, then you will get an error. No, definitely. Similar is also allowed, different is also allowed. There's no restriction like we have the restrictions in arrays that you can have only similar elements, not the different one. In structures, you can have similar also and the different one also, right? Okay, now let's see that how this DOB variable will look like in memory. So as soon as the date of birth variable is declared, memory will be allocated. So let's say this is your RAM memory, and somewhere in your RAM memory, the variable DOB is declared, right? So how many bytes it will take? So the first one, it will take your, how many bytes? 4 bytes, right? This is int month, it's 4. The size of integer is 4, so it will take 4 bytes. Day is also integer, so it will also take 4 bytes. Year is also integer, so it will also take 4 bytes. So what will the total size for this variable? It will be 4 plus 4 plus 4, which will be 12 bytes. So the size for your variable DOB, it will be equal to 12 bytes, right? Obviously, when you calculate the size of a structure type of variable, we need to consider structure padding also. That we'll be doing in the upcoming lecture series. Okay, but for this time, you have to understand only that this is the structure. This is how we define the template for our structure type, right? And this is how the size will be calculated. And then this is how you are going to declare the variable, right? Now, when the variable is declared, it is going to get memory. So let's say this is first 4 bytes. This is your month. This is the DOB variable. And under the DOB variable, this is the month. And this is the day. And this is the year. Right? Now, after declaring DOB, now next challenge that you get is how you are going to access each of this part of your DOB variable. Now, this DOB variable is not having only single value. This DOB variable contains multiple elements, which can be same, which can be different, right? So the way to access the variables is noted down. So to access the variables, we use dot operator. Dot operator is used to access structure members. Now you will say, what is the structure members? I don't know it. Okay, so structure member is basically these variables that you declare inside the structure. We call them as members of the structure, right? These int x, y, and z, these are what? These are the members of the structure, right? So to access these members using a variable DOB, which is not a pointer. Now you can have a variable which can be pointer, which cannot be pointer, right? Now here DOB is not a pointer, just like this variable A is not a pointer, right? So if it is not a pointer, we are going to use which operator? Dot operator. So here to access each and every member of this DOB variable, you'll be writing DOB dot month, DOB dot day, DOB dot year. This is how we initialize your structure variable, right? And this is how you are going to print the values of this variable again. You're going to write printf %d, DOB dot month, printf %d, DOB dot day. Dot DOB is mandatory. Why? Because if you're not going to write DOB dot, You are just printing printf %e comma month, printf %e comma day, printf %e comma year. What will happen? Compiler will say, I don't know this month, day, and year. Why? Because these members are declared inside the scope of the structure. Remember that scope means a single block. What is a block? A block is nothing but you create by creating a curly bracket. So here, these two curly brackets, they are creating a single block. So these variables are part of the structure only. Similarly, these variables are the part of this structure only. So to access their values, you need to tell the compiler that this month is part of date. And how you are going to tell? By using a variable, you say dub dot month, dub dot day, dub dot year. I hope now it is clear, right? Okay, now let's try to run the program on the online compiler so that you can understand this concept much better, right? And after this, we are going to wind up this session. So first, I'm going to create my structure. So for creating the structure, I will write over here the struct keyword, struct, and let's say I write the data type as my type. Then after this, I'm going to declare the variables. I will write int x. Then I will write, let's say, float y, char z. We'll talk about the how you can initialize, how you can declare the variable of type array of character string, but not in this lecture. We will do it in the next lecture. Okay. Okay. Now here you have declared the structure. Now to access the values to declare a variable, there are two methods. One, over here you can write struct keyword, name of the type, my type, comma variable name. Let's say variable name is A. Right? This is local variable. Now, if you want to create the global variable, now we can have a global variable of type user-defined data type. Yes or no? Yes, we can have. So the way to create the global variable is we write directly with the global definition of the structure over here. So here global becomes the global variable, right? And let's say this is the local variable. So let's say I write local var. And this is the global variable. This is the global var. Okay. Now to initialize the values, I will be writing my variable, local variable, variable name, but you cannot write variable name equal to some value, right? Because local it's not a normal variable, it's of type struct. So under the local variable, you have some three portions further. So you'll be telling which value. So I'll be writing local var dot x equal to 10. Similarly, local var dot y equals to some float value, let's say 12.34, and local var dot z equals to some character, let's say capital A. This is how you are going to access. Now let's try to print their values. So to print the value, you'll be simply writing printf integer value is equal to %d, comma, local underscore var dot x. Again, over here, you need to write dot x. Your variable name dot x, not only x, right? In the same manner, you can print the other values also. Paste. Here it will be dot y. Float. For float, we write f, and here we'll be writing float value. Float value is equal to %f. Similarly, you are going to print the character value also. So here you will write character value is equal to %c, and here it will be dot z. Now let's execute this program. Run. So here, when you run the program, you're getting this output, right? So if you want to display the values for the global variable, you can display it in the same manner. But since the values for the global variable is not initialized, and we know the default value for global is always 0. So for all these numbers, you are going to get 0 value. But for character, it will be an empty character. Clear? So this is a part of your work. You can try to print the values of a global variables over here and answer the write down the answer in the chat box below in the comment section. Thank you so much. If you like the video, please do like my channel, subscribe it, and please share it with your friends also. Thank you.